Alright, this is going to be the review video. I just recorded this entire thing only to find out it didn't record, so if you hear the disappointment in my voice, just ignore it. Okay, so for this first one, we are using the first fundamental theorem of calculus. So we're going to take the antiderivative here, which is 2x squared divided by 2, and we're going to evaluate it from 0 to 1. Now notice the 2's here cancel out, so we're just left with x squared evaluated from 0 to 1, which would be 1 squared minus 0 squared, which just comes out to 1. Alright, on the second one, we're going to do the same thing, except we have 2 terms instead of 1. So our antiderivative would be x squared over 2 minus 2x, evaluated from -1 to 0, which would just become 0 squared over 2 minus 2 times 0 minus all of -1 squared over 2 minus 2 times -1. So this first part is just going to become 0 since we're multiplying by 0, which would mean our answer would be negative. -1 squared would just be a positive, so 1/2. -2 times -1 is positive 2. And then if we simplified that, it would become -5 over 2. Alright, the third one, same thing. So it's going to become t to the third over 3 minus 2t evaluated from -1 to 1, which would equal 1 cubed over 3 minus 2 times 1 minus all of -1 cubed over 3 minus 2 times -1. So the first part's going to become 1/3 minus 2 minus -1 cubed is -1, so -1/3 plus 2. And if we distribute that negative, this would become 1/3 minus 2 plus 1/3 minus 2. So if we simplify this, you get these become 6 over 3. So -6 over 3 plus -6 over 3 is -12 over 3. Plus 2 over 3 would just be -10 over 3. Alright, number 4. So for this one, we don't know how to do it if there's a square root on the outside. So I'm going to go ahead and multiply this out. So it'd be 2t minus 1 times 2t minus 1, which would end up being 4t squared minus 4t plus 1. So we'd have the integral from 0 to 1 of 4t squared minus 4t plus 1 dt. And the antiderivative of that would be 4t cubed over 3 minus 4t squared over 2 plus t evaluated from 0 to 1. So then we would get 4 times 1 to the third over 3. 4 over 2 just becomes 2, so 2 times 1 squared plus 1 minus, and then all of this over here is just going to become a 0, so I'm not even going to bother writing it. So we have 4/3 minus 2 plus 1, which really equals 4/3 minus 1, which would just equal 1/3. Alright, 5. So for this one, I'm going to rewrite it as the integral from 1 to 2 of 3x to the negative 2 minus 1 dx. So when I take the antiderivative, you get 3x to the negative 1 divided by negative 1 minus x evaluated from 1 to 2. And then that really just equals negative 3 over x minus x evaluated from 1 to 2. So we get negative 3 over 2 minus 2 minus all of negative 3 over 1 minus 1. So the negative 3 minus 2, that would be negative 7 over 2. Negative 3 minus 1 would be a negative 4. Then minus negative 4 becomes plus 4, which is really 8 over 2. So 1/2 would be our answer. And the last one is 6. When you take the antiderivative, you get t to the 4/3 divided by 4/3, which is really just 3 over 4, minus 2t evaluated from negative 1 to 1. So I have 3, 1 to the 4/3 over 4 minus 2 times 1 minus all of 3 negative 1 to the 4/3 over 4 minus 2 times negative 1. And 1 to the 4/3 is just 1, so this is going to be 3/4 minus 2 minus all of negative 1 to the 4/3 is still a positive 1, so 3/4 plus 2, which would end up being 3/4 minus 2 minus 3/4 minus 2. So the 3/4 would cancel out, and we'd just be left with negative 4 as our answer. Okay, the next one, we're going to be using properties of integrals for these 5. So the first one we have from 9 to 1. Notice that's in the wrong order because 9 is bigger than 1. So we can rewrite this as negative, then the integral from 1 to 9 of f of x. So then it would be negative 1, because we get that information from up here. So then it would just be positive 1 as our answer. Okay, for 8, we're going to split this up into 2 different integrals. So it's going to be the integral from 7 to 9 of f of x plus the integral from 7 to 9 of h of x dx. Then we just use the information they gave us. So for f of x, it's going to be equal to 5. For h of x, it's going to be equal to 4. So our answer would just be 9. All right, for 9, it's looking for the integral from 1 to 7. So that's not one of the ones given to us. But to get that, you could just take the integral from 1 to 9 of f of x and subtract the integral from 7 to 9 of f of x. And then that would give you the integral from 1 to 7 of f of x. So from 1 to 9, it's going to equal negative 1. Then minus from 7 to 9 would be 5. So negative 1 minus 5 would equal negative 6. Erase this just so I have extra room over here. Alright, for 10, I'm going to bring out those constants. So it's going to be 2 times the integral from 7 to 9 of f of x. Then I'm going to bring out the negative 3 for the h of x. So negative 3, the integral from 7 to 9 of h of x dx. Then we just have to simplify these by plugging in what we know. So the integral from 7 to 9 of f of x is 5. The integral of h of x is 4. So then that's 10 minus 12, which means negative 2 is our answer. Alright, and number 11, notice it's backwards again, so the 9 is on the bottom. So we have to make it negative when we change it. So it would be negative the integral from 7 to 9 of h of x dx minus, and then we're going to flip the f of x as well, so that one's going to be negative the integral from 7 to 9 of f of x dx. And since it's minus and negative, that's really going to become a plus there. So we have minus the integral from 7 to 9 of h of x is 4 plus the integral from 7 to 9 of f of x is 5. So negative 4 plus 5 would just equal positive 1. Alright, 12. Erase this. So this time we're going to be finding our values using area under the curve, and we're actually going to have to calculate the area. So I'm going to start with finding g of 3. So for g of 3, that would be the integral. Since it gives us g of 0, it'd be from 0 to 3 of g prime of x would equal g of 3 minus g of 0. And to find what this integral would be equal to, we just need to find the area under the curve from 0 to 3. So that's going to be all of this, and then half of this triangle. So everything I have shaded there, we need to find the area of. The first thing is this quarter circle, so that would be 1/4 pi r squared. And notice our radius here is 2, so 2 squared. 2 squared is 4, so that cancels out with the 1/4. So the area of this would just be pi. And then with the triangle, the base is 1, the height is 3. So 1 times 3 is 3, divided by 2, that would be 3/2 for the triangle. And we don't know g of 3, that's what we're trying to find, but we know that g of 0 equals 5. So really, g of 3 is going to equal pi plus, if we add 5 to both sides, that's really 10 over 2, so 13 over 2. Alright, let me erase this so I have room to do the second part of this. So now I need to find g of negative 2. And that's going to be the integral from negative 2 to 0. So this time we're finding our initial value instead of the final. Of g prime of x dx. And that would equal g of 0 minus g of negative 2. So this time I need the area under the curve from negative 2 to 0. Which again is just going to be a quarter circle. We learned that that area was just pi. So we have pi equals g of 0 we know is 5 minus g of negative 2. So we'd have pi minus 5 equals negative g of negative 2. So if you divided that by negative 1, you would get positive 5 minus pi equals g of negative 2. So 5 minus pi. Alright, 13. We're basically going to be doing the same thing. And we're trying to find g of 0. So for this one, I'm going to set it up the same way. They gave us g of 3, and I'm trying to find g of 0. So that's going to be from 0 to 3. And then this graph is of f of x. And then since g is the antiderivative, it's going to be g of 3 minus g of 0. So we need to find the area under the curve from 0 to 3, which would be that trapezoid on top and the triangle on bottom. So base 1 is going to be 1, base 2 is going to be 2, divided by 2, and then our height here is 1, 2, 3. So that right there is the area of the trapezoid. And the area of that triangle is below the x-axis, so it's going to be a negative. The base is 1, the height is 1, so base times height is just 1 divided by 2. That makes the area a half. We know g of 3 is 6. We're trying to find g of 0. So now we just simplify this. 1 plus 2 is 3 times 3, so that would be 9 halves minus 1 half equals 6 minus g of 0. So you'd get 8 halves, which is 4. Then you subtract the 6. So you get negative 2 equals negative g of 0. Divided by 2, both those become positive, so positive 2 would be your answer there. Okay, now we're on to Riemann sums. So it's talking about a rocket has a positive velocity, and the velocity of the rocket is given in this table. So part A says, using the correct units, explain the meaning of the integral from 1 to 70 of the velocity. So if we look here, this table gives us 0 and 80. You don't really need those. But we know that if you take the derivative of position, you get velocity. So that would mean from 10 to 70, the integral of velocity, that would just equal the position at 70 minus the position at 10. So we need to explain this meaning. If you're taking the final position and subtracting the initial position, that's really just the displacement of the rocket. And then it says it wants units, so if we look, our units here would be feet. And now for the rest of these, we're going to use Riemann sums, and it wants 3 equal subintervals, so I'm going to go ahead and draw those in. We'd have from 10 to 30, 30 to 50, and 50 to 70. So for the left one, we're going to start way at the left, so we're going to have v of 10, and then the width for all of these is going to be 20, then v of 30 times 20, then v of 50 times 20. Then using our table, we can get all of those values, so v of 10 is going to be 14, V of 30 is 29. V of 50 is 40. And then you could definitely just leave it like that, but I'm going to go ahead and factor out a 20 and figure out what the answer is. So 20 times 14 plus 29 plus 40. I'm going to use a calculator here. It would give you 1,660 feet. So that would be the displacement of the rocket if we were doing a left Riemann sum. Now for the right, we're going to start at the right side instead. So I'm going to have V of 70 times 20 plus V of 50 times 20 plus V of 30 times 20. Then if we substitute in all those values, you have 47 times 20 plus 40 times 20 plus 29 times 20, which would be 20 times 47 plus 40 plus 29, which would give you 2,320 feet. So that would be our estimation using a right Riemann sum. Now for midpoint, we're going to be using the 20, the 40, and the 60 because those are our middle values. So we would have V of 20 times 20 plus V of 40 times 20 plus V of 60 times 20. So that would be 22 times 20 plus 35 times 20 plus 44 times 20. And then using the calculator, let's see what we get. So that would give you 2,020 feet. And then the last one we have is going to be trapezoid. Y'all's favorite. So this one is going to be V of 10 plus V of 30 divided by 2 times the height of 20. Then we'd have V of 30 plus V of 50 divided by 2 times 20. And then V of 50 plus V of 70 divided by 2 times 20. And for all of these, notice the 20 and the 10. 2 become a 10. So I'm just going to factor out a 10 and see what we get. So V of 10 is 14. 30 is 29. 29 again. 50 is 40. And then V of 70 would be 47. So let's use the calculator, see what we get. 14 plus 29 plus 29 plus 40 plus 40 plus 47. And that gives you 1,990 feet. So that's pretty close to the midpoint estimation. And that's how you do all 4 of those. Alright, the last thing we need, this is where you get to use a calculator, Desmos or TI Inspire, whatever you have. So this first one says a car sold for $16,000, depreciated at a rate of 2e(x to the $2) per year. What is the value of the car after 3 years? So we know it started at 16,000. Depreciating means it's going down. And then we're going to take the integral from 0 years to 3 years of 2e to the power of x squared dx. So what I need is Desmos now to figure out what that integral would equal so we can find our answer. So let's see. Nope, that's not it. Just downloaded it. There it is. Alright, so you type in int here. And then it was from 0 to 3. And then, what was it? 2e to the x squared. So 2e to the power of x squared. Don't forget the dx here. And we get 2889.090. 2889. So be careful, that is an answer choice, but that is not the right because we have to subtract it from the original starting value. So you would get 16,000 minus 2,889.09, and then that would give you 13,110.91, which would be C. Alright, and the last one, number 16, the acceleration of the object is defined by the square root of 1 plus t squared. Tells us the velocity at t equals 6, and then we need to find the velocity at t equals 1. So let's just set this up. So we know we're going to go from 1 to 6. Then here's our function, 1 plus t squared dt. And then if it's acceleration, that would be velocity, so v of 6 minus v of 1. Again, we're going to use a calculator, so from 1 to 6. Just go ahead and erase all that. It's going to be a 6. And then it was the square root of so you get 18.346. And then we know that the velocity at 6 is 22. And we're trying to find the velocity at 1. So I'd subtract 22 from both sides. And 18.346 minus 22 would be negative 3.654. And that equals negative v of 1. So 3.654 would equal positive v of 1. So B would be the answer.